CPUs have been around since the late 1970s. Well, let me rephrase that. CPUs have been around a lot longer than that, but CPUs for PCs have been around since the late 1970s. And as you might imagine, we've had a few improvements over the years. In fact, we've had zillions of improvements. Now, as things get faster and the buses get wider and the processing power becomes stronger, as you might imagine, the physical CPU itself is going to have to change a lot. And these different types of physical packages for CPUs are what we call the CPU sockets. Now you have to be a little bit careful here, because when you say socket, most people think like a light bulb and a light socket, but we use the term socket to define not only the shape and the pins and the form of the CPU, but also the actual socket that the CPU fits in. So we could talk about a CPU having a particular size, which we call the socket, as well as the socket itself. I didn't invent this stuff, folks. Anyway, so in this episode, what I want to do is concentrate on how CPUs progress and the different types of sockets that we know and love. So first of all, what I want you to do is take a look down here. I've got 3 different CPUs right across my mat here. As you look at these CPUs, on a casual glance, you'd say that they are extremely similar. In fact, the 2 over here on your right look downright identical. Well, they're not. What's happening here is that Intel and AMD will come up with new what they call microarchitectures. In essence, it's the circuit diagram on the inside of the CPU. Now, a CPU isn't put together through soldering. It actually uses a photolithographic process. If you've ever silk-screened a t-shirt, it's surprisingly similar. But instead of putting ink onto a cloth t-shirt, we're actually etching away layers of silicon using very, very caustic chemicals and creating millions, if not billions, of little tiny microscopic transistors, which actually creates the CPU itself. So as a new feature becomes developed, they have to redesign this entire thing, and this is why we say it has a new microarchitecture. So what will happen, and both Intel and AMD do this, but I'm going to concentrate on Intel because they're more complicated and a little bit more interesting in some cases. What they'll come up with is a new design, and these new designs will get family names like Nehalem or Haswell or Kaby Lake, and they make all kinds of different CPUs from that. So, for example, they'll create one new microarchitecture. We'll say Coffee Lake. And once that microarchitecture is made, Intel will then make a broad cross-section of CPUs to cover different types of needs. In this case, Intel uses what's known as the I values. So they'll say things like an i3, which is based on a particular microarchitecture, but that's the lower end. It will probably have less cores in it. It won't have as much cache built into it. It won't run quite as fast. Then there'll be an i5, which will be more of a mainstream type CPU. It's the same microarchitecture on the inside, but certain things are turned off and certain things are turned on depending on how it comes out of the assembly line. So after i5 is i7, and then i9. So what will happen is you'll pick one well, we don't pick it, Intel does, picks a single microarchitecture and then creates a broad cross-section of different models of CPU based on that one single microarchitecture. So let's just go and do a quick rundown of some of the microarchitectures we're seeing today. Now keep in mind, this is interesting because this nomenclature of i3, i5, i7, i9 has been around for about 10 years, and it's probably going to be sticking around for a while. So let's go ahead and do a quick rundown of the different names of the microarchitectures used on the Intel i3, i5, i7, and i9s. So literally the first one is called Nehalem. Then a few years later we came up with Sandy Bridge, Ivy Bridge, Haswell, Broadwell, Skylake, Kaby Lake, and Coffee Lake. Now, if you count these, there's actually a number involved. So Nehalem would be the first version of the i3, i5, i7s. i9s weren't quite out yet. And then we would have Sandy Bridge would be second generation, Ivy Bridge third generation, Haswell fourth generation, Broadwell fifth generation. You get the idea? The reason this becomes really, really important is that as Intel keeps changing these, we come up with new types of sockets to handle these new types of CPUs. Because one day you'll be looking on a computer and you'll go, oh, this is an i7, but this could be an i7 processor from 2010, a much earlier generation, and other than the name i7, it is a completely different processor than a modern i7 that we might see today. So that's why we really do concentrate on these different types of family names when we're talking about microarchitectures. So the big place this comes into play is when we actually take a look at a CPU. Now these are going to be terrible, so let's put a screen up. So on the CPU itself, it's going to say i7, and then there's usually a dash. Then we're going to see a number that's 2 through 9. Now you'd say, wasn't there a first generation? Yeah, but they never used the 1. The next thing you're going to see is the SKU, the sales inventory code. We use SKUs on toasters, but within Intel that code defines that particular one. And then you're going to see something in there. Sometimes you'll see a value like a U or something like that that defines like it might be particularly low power or some feature like that. So this is an example of an exact make and model for a very, very specific CPU. Problem is when you look at that number, does it tell you how many cores does it have? Does it tell you how fast it's running? Does it tell you how big the cache is? No, it doesn't say anything. So this is always a big challenge for us when we're looking for a CPU. So we say, ooh, I want one of those new Intel i7s. So people are going to say, well, you know, what microarchitecture? And you're like, well, I'm thinking one of those Coffee Lakes might be the thing. So you can get that information, but after that, it's going to take some research, folks. There's a reason a lot of people buy pre-assembled systems. And we don't, because we're nerds and we love all this stuff. But for a lot of people, going through the process of making sure you have the exact right CPU for the exact right motherboard, what you need, requires just some good research at this point. Okay, now each one of these different versions is going to have a different type of configuration and a different type of ability. You could literally have, and you need to be careful about this, you could have i7 processors that span multiple microarchitectures that have the exact same socket. Or worse than that, you can have lots of different processors that are all using different sockets. So again, the bottom line is you're going to have to take some time and you're going to have to research. If you hear about some new CPU, that's great. That's how we all start. But you need to research to make sure you're getting the right guy. All right, so what I want to do right now is kind of go through the different type of sockets that you're going to see. So first of all, take a look right here. When we talk about sockets, one thing I want you to notice, you see this particular CPU has pins sticking out of it, and this one doesn't. When we talk about socket names, you're going to see the term PGA or LGA. PGA stands for Pin Grid Array, and it basically means there's a bunch of pins sticking out of the bottom of the CPU. LGA stands for Land Grid Array, and instead of having pins, it has little lands or little pads, and the actual socket we drop it into has little pins to make the contact. So when you're talking about these terms, make sure you're always going to be saying LGA or PGA. Now, what I want to do now is talk about the difference between Intel versus AMD. So let's take a look down here one more time. What we're looking at are two motherboards. Now at first glance you go, well, these are pretty similar motherboards, Mike. Well, they are similar, but one of them over here, this is a AMD motherboard, and this guy over here is an Intel motherboard. The reason I know that is, well, I read the box before I put them down on the pad, but also because I'm used to looking at sockets. For example, this socket here, this is a pin grid array type socket, and AMD calls this an AM4. And we can use this. This is a little zero insertion force. We'll talk about this more as we actually install them. And this guy over here is called LGA, you ready? 1151. It's actually interesting with Intel CPUs because the LGA is Land Grid Array, but 1151 is actually the number of pins itself. So there are 1,151 pins. We have processors out today that have well over 2,000 pins, so this is not as big as it gets. It gets a lot bigger. Now, the actual exam itself is not going to be quizzing you on all these different types of socket types, but I would like to bring up 4 different sockets that you might see on the exam. Let's take a look at those. On the Intel side, there's two in particular I want you to be aware of. Number one is LGA 1151. LGA 1151 is more of a mainstream type of socket. So we'll see a lot of the middle of the road type CPUs moving into the enthusiast side. Second is LGA 2066. LGA 2066 is very much in the enthusiast world. Higher end CPUs like very high end Intel i9 processors will use this particular type of socket. On the AMD side, it's really down to only two types of sockets these days. Number one is the famous socket AM4. AM4 is, again, pretty much goes neck and neck with LGA 1151 in terms of mainstream to slightly on the enthusiast side. And the big groovy one today is TR4. TR4 is used on enthusiasts and high-end workstations today. So it's really important to me that you take some time and understand that just because you have a particular type of CPU, it may not have a unique type of socket. One microarchitecture can span many of them using the exact same socket, and you could even go in the opposite direction. So you need to be very, very careful with this. So when you take a look at sockets like this, in fact, I even want to throw one in here. These type of sockets have been around for a long, long time. This right here is about a 20-plus-year-old socket. And this is just another example. Just by looking at it, I can tell it's a PGA type socket. So sockets have been around for a long, long time. When it comes to sockets, make sure you have some comfort with microarchitecture and some of the family names. And also, when you're buying a CPU, make sure you get the right socket. Not to say that I've ever done it, but can be a little bit embarrassing returning a CPU because you got the wrong socket.